Right, good morning. So I was at the meeting in Paris in 1993, and I was at the beginning of my career, and I don't think I contributed very much to that meeting. So 22 years on, I'm at this meeting, and I hope I can contribute a lot more to it. The next meeting would be really nice if it was somewhere a bit warmer, somewhere a bit cheaper, and somewhere where the young mycologists are beginning their careers. Let's go back to the start again. The title of my talk is supposed to be on linking morphology with phylogeny. Does it work? This is quite a difficult topic to talk about, so I expanded my topic. Are morphological characters still useful? So I'm going to talk about those things throughout this talk. Ever since I started working, I've been working in morphology. That's my love. And we use other techniques to sort out the morphology. There tends to be a feeling or a thinking that people who work on morphology, it's not such a great thing. And I want to try to dispel that thinking for the younger people who mostly aren't in this room. So I'm going to take this opportunity to do a little bit of history, a potted history. So the first few slides are for the over 55s, a bit of nostalgia. So I did my PhD at Portsmouth University, and those of you will remember, we only had typewriters then, no word processing. We had books. You couldn't go to the internet and download all the papers. Who remembers this? Some of you, right? And we only had morphological characters. That's all we had to go on. And so most of the early taxonomy and classification was based on morphological characters. And everybody did their best, but that's all we had. So this is where I graduated, and perhaps you'll recognize this young man there. That's Gareth Jones. And he's really been the inspiration. He introduced me to mycology. I was a zoologist before I started. And he has helped me throughout my career. And a bit of nostalgia. This is what I used to drive when I did my PhD. This is what I drive now. So let's go a little bit forward. My first job. Unlike most of you, I finished my PhD and I hated living in UK. I wanted to go back overseas. So I got a job in Brunei as a teacher. And so I was lucky. We only worked in the morning. And then every afternoon, I went into the mangrove swamp with my canoe, collected and spent all my time looking down the microscope. It was really lovely. And during that time, I published several papers. So eventually, I managed a research job when I emigrated to Australia. So now we go to the over 55s. We're going to fast forward a little bit. And thanks to Gareth, I got a job in the University of Hong Kong and started applying molecular phylogenies to my research. So these are very early days of molecular phylogeny. And so these are some of the paper. This is 2006, where we looked at the Pleospiraceae. So I'm going to keep talking about Pleospiraceae as a theme throughout this talk. So what were the problems with these early works that we did? Most of the cultures which we used, they came from culture collections. So we really had no idea whether the fungi we were working with were correctly named. And so these early trees were making progress, but they weren't that great. And we also we did our own sequencing from these cultures that we got from culture collections. Really, there wasn't much of an effort to recollect new taxa and sequence new taxa. And this is a paper that we published, I think, 2010. And this is where we started to have our own collections of fungi. We did our own sequencing. And the trees started to be a little bit better, but most of our cultures were from culture collections, or they were from AFTO. The theme here is that many of these cultures we used and the sequence data were not linked. And we couldn't really be sure, making nice trees, but we couldn't really be sure what the fungi looked like and whether they were correct. So in this paper, we introduced the Magnaporthales, and in the last couple of days, this has been shown actually to be a good order. Okay, so then we come on to one fungus, one name, and this is a first attempt that we did in our group where we tried to compile all the asexual data and sexual data and put it into one paper. And so I went through the dictionary of the fungi and compiled this big list of asexual and asexual fungi that were supposed to be linked. If you actually go back and look at this now, and we recently did this for the Sordereomycetes, almost all of the links are fictitious. They're not real links. There's no evidence for most of them. And then Ying, who'll be talking tomorrow, did her work on the Pleosporales. And she looked at all the sexual genera. But it was a lot of hard work to get her to think about the asexual genera and write about them at all. So we were not making much progress linking them. And this is a similar paper in 2011. So one of the nice papers, again, is Professor Jones. He really has tried to link the asexual and the sexual fungi in the marine fungi. And this is his tree, but unfortunately in this tree there aren't many links. And then in the Studies in Mycology issue, you can see in the blue a lot more marine fungi, a lot more new sequence data. And so we were starting to get a much better tree produced. And then this, the comrades' paper on the Dothidiomycetes, a lot more data becoming available, and we're starting to get some quite nice results. So the initial attempt was based on morphology, based on linking data. So then we move on to the families of Dothidiomycetes paper. A lot more new molecular data and trees, and we actually bringing in the asexual fungi into the sexual classification or into the natural classification. And this particular paper, which is the families of Dothidiomycetes, we had descriptions for each family, notes for each family, the strict description of the type, other genera, and keys, and then a plate for each family. So then the outlines start to incorporate asexual genera. So the outline of Dothidiomycetes used molecular data and started to link asexual and sexual genera. And this was a paper published by Nalin. Now, most of my students' names are not pronounceable, so I'll keep to their first names. But this was a big community project where we linked the asexual and the sexual genera in the Dothidiomycetes and produced a new tree for this. And we came up with one name for the fungi with big agreement from the community. And so this was the outline. For instance, Didymos feriaceae containing both asexual and sexual genera, and notes on the changes. Now I come on to the last bit of this, and then I will actually show you some fungi. So the last bit is a paper that we were just bringing out, which is on the Sordereomycetes. It's a backbone tree for the Sordereomycetes, and for this we've linked the asexual, we have the asexual and sexual genera in the natural classification. So that's the paper, and this has, this is concatenated trees, and then we have the outline, and then notes on each of the changes. So throughout this period, this history, morphology has always been important. And in 2010, I wrote a paper in Mycotaxon. And the problem with our work up to 2010 is that we were using data from culture collections, which may have been correctly named, they may not have been. And we needed fresh collections. So in here, despite recent molecular advances, there is an unprecedented need for mycologists to return to the field, recollect species, and epitypify and so on, sequence. Now, I wonder how many of us have been doing it. In Thailand, in China, we've been making a big attempt to go out and collect the Ascomycetes. and provide the data which is necessary. But we need to do this more and more and more. So let's move on to the answer. Is morphology still useful in our classifications? Is it still useful? So the first thing is the name is useful. The name and the morphology are linked. You cannot separate them. So for instance, if you say Aspergillus, everybody knows what we're looking at. Or if you have a plate of Aspergillus and you look at it, you already know it's Aspergillus. So the name and the morphology is linked together. So a summary between 82 and now, morphology is really important. To sit at the microscope, look at fungi is essential. In 82 to 98, we were using SEM and TEM to enhance our decisions. Now we're using sequence data, but these are all techniques to enhance the decisions we're making about the fungi. And now we're starting to use whole genomes. So everything is based on the name, and all names are based on the morphology. So since this is for Emery Simmons, I'll talk about the Pleosphoraceae now. So this is the type of Pleospora, and it has a stemphyllian anamorph. So Pleosphoraceae and the Pleosporales. And if you do sequence data, you can link these two. You can also link them in culture. Now, this is Alternaria, and recently we found a lot of sexual states of Alternaria. And this is one which we've just published. This is actually the sexual state of Alternaria alternata. And we have many more now. Again, you can link them in culture, and you can link them by molecular data. So this is what we've done here. So in the Pleosphoraceae, there is the Alternaria sexual state, there is the Stemphylium, Pleospora, sexual state, and the Comoclathis. They are all these pleosporoid fungi. So my student in China, Thailand, has been working on pleosporoid fungi. So you can look at all these. Do you think they all belong in the Pleosphoraceae? So let's just look at some. This is the Lenticisiaceae, one of the families. And this is typical Lentithecium. Where is it here? D. That's what the family looks like. This is typical of the family. Now this one down here also belongs in Lentitheciaceae, so that's got muriform spores. So we've got Pleosphoraceae, we've got Lentitheciaceae. This is Phoma, the real Phoma. And so this is Didymela. This is what you think the Didymelaceae looks like. That's what it looks like. But there's also Phoma species in the Didymelaceae, which also have these pleosporoid spores. Now let's go to this, back to this slide again. These are, 11 pleosporoid spores. This is the tree. So my student has made a very simple tree here in the Pleosporales, and you can see that each of these are scattered down here. So all the different spores come in different families. So for instance, the top one here, this is Phaeosphoraceae. This one here, Camerosphoraceae. This one here, Pleosphoraceae. And you go on all the way through. So almost in every family in the Pleosporales, there are examples of pleosporoid spores. So the reason I've shown you these is because can we use the morphology to predict the family? The answer is probably a bit difficult, unlikely, hard to do. There are other families, other orders which also have pleosporoid spores. So this is the Hysteriales. Now this particular group have very distinct ascomata. So you could actually look at that and you say this belongs in the Hysteriaceae. And then this family that I won't try to pronounce, if you find this, you will know it belongs in this family. These are very unique. This is the Ascomata, and it has a long stalk. Now these live in fresh water, and this characteristic is probably so that the Ascomata can lie in the fresh water where it releases its spores. So if it has this character, you know it belongs in this family. So there are some families where you can use characters to place the fungi. Now, maybe some of you know what this is. These are helicoid spores, and these chlamydospores. This amazing structure here is a helicoid spore coming out of a conidia. But if you get these fungi, you probably could guess which family and order they belong in. Right? They belong in Tubufiaceae. So anything with most things, there are exceptions to every rule, which have this type of spore belong in the Tubufiaceae. Okay, so instead of using the sexual spore to place something, does it help to use the asexual state? So these are the fungi I showed you before, which all belong in different families, and these are their asexual states. So they're all look like phoma, asexual states. So you can see, at least in this bunch, you can't use the asexual state to predict the family. And if you move to some more families, there's another phoma-like one in the Melanomataceae. So in the Lenticthiaceae, you've got these Camarasporium-like spores, so a little bit different. If you've got Alternaria, you know it belongs in the Pleosphoraceae, and these belong in the Phaeosphoraceae. So in most cases, it doesn't really help if you've got the asexual state. You can't find the family, but in some cases, like Alternaria, it helps. You know for sure. So this is a rather nice fungus we found a couple of years ago, and you can see this is a Conidiomata. These are the Conidia, so it's really quite strange. So where do you think that would belong? So we sequenced it, and this belongs in the Lophiostomataceae, and this was described in Lophiostoma. But this was a really broad classification. So this is what Lophiostoma looks like. Hyaline spores, these crest-like necks on the surface. And this really was strange to be placed in there. And then recently we found the sexual morph of this fungus by molecular data, not by culture. And you can see it looks again like a Pleospora. If it has these spores, tetraploa, it belongs in the Tetraploisphaeriaceae or something like that. If you look at the sexual state, you have no idea which family it belongs in. But if you've got this asexual state, you can use it to place it at the family level. Okay, so I want to move on now to the example with plant pathogens. So with the higher level taxonomy, the characters, it's difficult to use the characters now to place things at the family level. With the pathogens, it's impossible to use the characters to name the species, almost impossible. So this is Colletotricum. If you get a Colletotricum and you want to name it to species, it's really difficult to do using morphology. You have to sequence it, and you have to use several genes before you can identify the fungus. Same with Diaporthe. Almost impossible now to identify a Diaporthe using morphology. And even this group, Pestalothiopsis, it's very hard to identify to species without doing molecular data. Same with Curvularia, a little bit better, but Bipolaris and Curvularia. So all of these pathogenic genera, we need molecular data really to identify them. And so this was all put into one nice paper where people can download and get all the information on the plant pathogens. So I'd like to talk a little bit about an initiative we have in Thailand, which is linking names with morphology. The biggest problem for us trying to make trees is that mostly the sequences are not linked to the morphology. So it's a real worry. So this is the web page, Faces of Fungi, and if you go into the Ascomycota, you get all the classes. If you go into the Dothidiomycetes, you'll get a list of all the Dothidiomycetes. And this is organized based on the latest papers. And then this is the Dothidiomycetes with the tree to all Dothidiomycetes. And then we can scroll down, just as an example, Phaeosphaeriaceae. So this is a write-up on the Phaeosphaeriaceae. There's a backbone tree to the Phaeosphaeriaceae. And Phaeosphaeria. If you want to know what Phaeosphaeria looks like, there's a description. There's the type species, the plate of the type species. Another genus in the Phaeosphaeriaceae, Aminographium. If you want to know the description, it's there. And so this is all linked. These are all published papers which have been put on this Faces of Fungi webpage, and these are all linked to molecular data, if molecular data is available. So both ways, you link both ways. So you can actually see what you're dealing with in this paper. Okay, so look at the time. Is morphology still useful? Well, yes, it's essential. Quarantine, it's very important. Ecology. If you have a load of fungi, if you don't know what their name is, it's very hard to predict what that fungi does. If you look at drug discovery, so we can look at Pestiloteopsis here, a very creative genus. Now the recent data we've done, the recent work we've done, we now know there are many species in Pestiloteopsis, and there are 3 genera. So we can look at each of the species, we can look at each of the genera when we're doing, looking for drugs in these fungi. These are the plant pathogens caused by Pestiloteopsis. And the recent paper with Pedro, we actually separated this genus into 3 genera. Now, when you're looking for drugs, is Pestiloteopsis so creative? Is it stumbled on by chance? And what about all the other species? Do each species produce the same chemicals? Do different species? Now we know what the species are, so we can look at all the species. Do the genera, the 3 different genera, produce different chemistry? And what about all the other genera in the family? So if you look at the family at the moment, Amphispheriaceae, are any of these taxa related to Pestiloteopsis, these ones like Discostroma? Maybe they are equally as creative in producing novel chemicals. Let's leave that. Now, with new generation sequencing, we end up now with a lot of OTUs. The more we put sequence data for species in GeneBank, the more fungi will be named. So at the moment, if you look at a new generation sequencing paper, there was recently one on sooty molds. There were about 70 taxa in the one sooty mold colony on the leaf surface. Now, how many of those taxa are actually active? They were all mostly OTUs. They couldn't put names on hardly anything. How many were actually active in the sooty mold community? Now, the more we can put names, we can say that fungus does this, that fungus does that. Biotechnological research. I've talked about that already. Now, so the main point here is, are families useful? Now, perhaps we need these families because for the user. And the ones, so if we have the family name, we can then write a monograph on that family. Now, that's very useful to the user. So, for instance, this paper here. If you're interested in this family, you've got a paper now just on this family. So, for the user, it's very useful. I want to thank here Erio. I ring that because he's my collaborator in Italy, and he's really a great mycologist and supplies us with lots of samples. Okay, I need to skip this slide. So all of my life I've worked on my morphology, and due to this, there's many things that have happened, and I've had a career. So for those of you working on morphology, it's a great thing to work on. It's really important, and it will really get you very far, I think. So this is the Mushroom Research Foundation, which is in northern Thailand. Now the whole of this is based on, solely funded by work on names, work on morphology. And this is the Mushroom Research Foundation in Chiang Mai. Now this, Tom will get a little bit excited about this because this is not for ascomycete work, this is for growing new species of mushrooms. But it's all based on morphology and names. So we're getting funding through that, not through anything else. And another thing we can be proud of as mycologists, the top 3 journals, phylogeny and morphology, the top 3 mycology journals. So I would like to thank all the work we've done. I'd like to thank my students. Without the students, none of this could be done. Now, Pedro visited me in 2009, and at that time we had 15 students. Now, in 2014, the number of students had grown to 40. Now, this is not Pedro, 4 years later. This is my father, who's 90, but I hope, Pedro, that you'll come out again soon and join us. Now, the point of this slide is 40 students, 30 of them are working on ascomycete systematics. And the ones in red are all either graduated or about to graduate. And in this part of the world, they all get jobs. And they all go on to careers in ascomycete systematics. So this is where the future is, China, Thailand, and probably Brazil, where the young mycologists are going to be taken over from us guys. So perhaps next time we could have the ascomycete systematics workshop in Thailand, China, or Brazil. Or Spain, it's warmer in Spain. And so my last slide, because we're on YouTube, this is my wife, son, and daughter, and I really want to thank them. Without them, I would not be allowed to do the amount of work that I do. Yeah, my wife, I wake up at 3 in the morning, turn the light on, and she just rolls over and goes to sleep. She encourages everything I do, so thank you to them. Okay, thank you.